Yeah, hello and welcome to Advanced Data Modeling in Power BI. My name is Markus and I work with models. And when I tell people that I work with models, they have some different pictures in mind what I do. So some people expect that I work with beautiful people, but instead I work with beautiful data and try to make data shine and make data useful for my clients and my customers. For this talk, I will concentrate on one hand on data modeling in general, but especially for Power BI and analysis services, Tabula. What is the specialty about Power BI Desktop and Analysis Tabula? It's not so much specialized, but there's some rules of thumb, there's some guidelines you should use when you model your data. And for those guidelines, Power BI Desktop and Analysis Services is optimized. That means if you follow those guidelines, will have a good data model, which is useful to your end users, but also Power BI and Analysis Services Tabula will easily make this model then performant because Power BI Desktop is optimized for a star schema. So use a star schema, one fact table in the middle and only the dimensions around and no relationships between the dimension tables. That's the thing. And it's optimized as well the storage engine, so where Power BI Desktop and Analysis Services Tabula is storing the data, but also the DAX language. If you have a star schema, writing DAX statements is much easier. DAX statements are not so complex in this case. Also, is the system optimized for one-to-many relationship? Yes, we can have one-to-one and many-to-many relationship in Power BI Desktop and Analysis Services, but it's optimized for one-to-many relationships. And it's optimized for unidirectional, so unidirectional filters. That means that filters going from one table to the other, but not the other way around, only in one direction. That means if you're new to Power BI Desktop, if you're new to data model, please read about everything you can get your hands on about star schema, about one-to-many relationship, about unidirectional filters, because this is what you should do. As this is an advanced talk, I will talk about exactly that, violating those rules for a certain reason. So I urge you, please do not use this talk as an excuse for not sticking to the best practices, for not having a star schema, for not having one-to-many relationships, for not having unidirectional filters. But there's rare use cases and those use cases are the reason why we can even model many-to-many relationships, why we can have tables which are no direction, have no relationship in the model at all, or that we can have key value pair tables and make them shine in Power BI Desktop. But this is not the goal. The goal is to have a star schema, and in some circumstances, it's good that we also have other possibilities. And exactly about this, we will talk in the next 45 minutes. So what I brought here is multi-fact models, models with more than one fact table. So some call this not star schema, but a universe consisting of several stars. We will talk about many-to-many relationships inside this multi-factor model in the first demo. I will also reach out to the concept of detached tables, where we have tables without any relationship in the model, but a true relationship from a business perspective, how we can cope with that. And if there is time at the end, we can also talk about key value pair models, which are many developers, many application developers are favorites because they're so flexible. You only have a key column, you only have a value column, and then you just put new attributes by having new rows, a new key and a new value, and the database does not have any constraints about it. Very cool for developers, but very hard for BI folks like me to make use of these tables to make reports, build reports on that. Well, let's see how we far are coming in this 45 minutes. So multi-fact model. Multi-fact model means that we have more than one fact table, and some, as mentioned, call this a universe. I'm not referring to the business objects universe here, but like to the fact that if there's more than one star, you could call this as a universe. The reason why we would have different fact tables, not usually, but that's the reason why you have different fact tables, is because the granularity is different. If the granularity of your transactions is the same, and with granularity I mean all the keys, the foreign keys to your dimension tables, if they are the same, then put everything in one table. If this is not the case, then we have to model this with two different tables. And at least they should share one hopefully more than one common dimension. Otherwise, I would not put this in one model, but make two different Power BI desktop datasets, different analysis services, tabular databases out of that. So only if there's common dimensions, then I would model this in one single model. My bet here is, I'm not sure if you ever heard about that, but there is this long named feature called direct query mode over Power BI and analysis services. This is currently in this is in public preview, so this is not fully supported yet. And this will allow you that in Power BI Desktop you can connect to different Power BI datasets or different analysis services tabular models. That means more than one. Currently, you can only connect to one of those models and use this for your reports, or you load your data, or you have direct query mode. With this feature, you will be able to connect to different models there. And of course, if you connect to different models, then you're creating a universe because those different models will have different fact tables in there, right? And then we're actually building a multi-fact model on your own, even if those two models or three or whatever are only a single fact model. But as soon as you start to join them together, this will be more common, and there's some things you have to take care of. So keep in mind that this is not trivial also for the end users. As a use case here, I brought budgeting. If you think about budgeting, usually the budget has a lower granularity than the actual data. Your actual data is like on timestamp level. Every time you have a beep in the supermarket, this is a transaction in our table. Of course, we will not come up with a budget for every second. We not even might have a budget for every day. Maybe we budget for the whole month. Of course, we will not have a budget for every single item in our store. Maybe we do it by product group level. Maybe we don't have a budget for every single store in our company, retail store, but maybe we have regions where we group it. So the granularity of the budget is on a different level than it would be at the actual data. So this is a good example of building a multi-fact solution here. And the solution is, I will present here, is either use trees. This is a DAX function. We will hear about that in a minute. We can build many-to-many relationships, or we could build a bridge table. And what's my favorite? You will find out in a couple of seconds during the first demo. Let's jump over to the 3DS example here. So what I have here is a really simple model. So you already see all the three tables from this model. It's only three tables, very easy model. The sales table only has 4 rows. So for the 1st of December, we have 2 rows, 2nd and 3rd of December for different products, the same product on 2 different days and a certain amount. Just random data. And we have 4 different products, right? 100, 110, 20, and 30. And for 30, we don't have any sales. So this is empty, but only for the first 3. And we can group those products. We have name for those products, and we also offer groups. So A and B, the first 2, are for group 1, which is the first 3 rows here, right? And then for the second group, only for 120, we have a sale here for 15,000. So that's the actual data. And when we take a look on my result table or visualization or whatever, then we see that we have month of December because we have the sales in December, right? Then we have 2 groups, group 1 and 2. That's the groups of our product. Then we have a sales amount of 33,000, which is actually the 3,000 plus the 20 plus the 10 for the first 3 products are part of group 1, right? That's what we get here. And the 15,000 is the one for product group 2, the 15,000 from down there. And if we sum this up, the total 48,000. Very brilliant. Power BI is so brilliant in being able to summing up those numbers, right? When we take a look on the budget is a little bit different. So the budget doesn't have any connection to the product table. So I tried to show you the model here. If we can also jump over to the model, then we can see from here that the budget and the sales table, so the sales table is filtered by the date and is filtered by the product. The budget is not filtered by the product. To make it easy here, I still filter it on day level from the date table. Maybe in a real world scenario, this will be also like only by month level, so we would have the same issue. But I only want to concentrate on one specialty here. So I still have a relationship with the date. My budget is on day level, but it's not on product level. And that's why I don't have any relationship here. And when we take a look on the numbers here on the visualization, this is funny. It's always funny having the same number repeating. So in many cases, there's some problem here, right? And at least when we take a look on the total, we know that 2 times 27 is not 60. So there's something wrong here. The reason why this is wrong is because of there is no relationship between the product and budget table. What do I mean with that? So the 27,000 is the 20 and the 7,000 from here. So the 27 is the number from here. Why do we see this number here? Because Power BI sees this is a visual and that we have a filter on the month, which is on the day, on the date table, which we don't see here, on the date and on the group 1 and group 2. So the date table is filtering the budget table. So we only see things from December 2021. The other budget, the second two lines, is actually from January, the next year. And of course, this is filled out, so we only see the 27 here. But why is this repeating numbers? Because we have two lines here. We also have the group levels here, the product group levels, group 1 and group 2, which is actually filtering the sales amount over the group and the product table. We see the corresponding sales amount for those groups, but there's no filter applied from the product table to the budget table, as you can remember. There's no filter from the product to the budget level. So what we are facing here is that we have two lines, but this filter group 1, group 2 is not applied on the budget level. Only the filter on the month level is applied to the budget. That's why we see the 27 here, 2 times. Because we have 2 times December of 2021. This is one thing. The other thing, why do we see the 60 here? The total in Power BI, in DAX, the total is never ever a sum of those lines. The total just is a total because the filter context is different. Here I see the 33 because the filter context is on day level December and group level group 1. That's why I see the 33 here. I see the 48 here because there's no filter applied, neither on the date table nor on the product table. And if you think about what's the total about our sales, this is the sum of those 4 numbers. This is the 48,000. And the same applies to the budget. So the budget, we see the 60,000 here because there's no filter applied neither on the month nor on the group. So we also see what's the result from our budget here, the 25 and 8,000. So if you sum up those 4 numbers, we will get the 60,000 here. By the way, if there are any questions, please ask them in the channel, in the comment section of this broadcasting. I will make sure that I read them. Unfortunately, there's some delay, so I will take some couple of seconds before I can answer them. Okay, so this is the reason here. So how can we solve this? One thing is this function called treat as. When I first heard about it, I only read about it, so I thought this is like a Greek goddess, Triatas or something like that. But it's treat as. So we're treating something as there would be a filter applied, even if there's no relationship. So what we do here is I have a calculate here, and I use the calculate, and the first parameter I pass in the sum of the budget. This is calculating the sum of my budget. And I use calculate, so I'm able to apply a filter on the second parameter of the calculate function. That's how we can apply or change or manipulate the filter context for a calculation. So the sum is not the sum, but it's the sum in the current filter context, which is then changed by my treat as function. And here I tell the system, please take the values from a product group and apply it to the budget product group. So I don't have a relationship in my model, but I apply a relationship on the fly with treat as. So I take all the values from the product group of the product table and apply them as a filter to the product group of the budget. And when we do that, we solve part of the problem. So now we see that we get like those numbers for group 1. We see the budget of 27,000. No, there's no budget on 27,000. This is the old one, this is the new one. Why don't we see something? Because if you jump back, for group 1, we don't have any budget. So this is right. So the first thing, check. The second one is for December group 2, we get the 20,000. So let's take a look here. On December, for the group 2, we have 20,000. This is right. And 7,000 for group 3. This is also what we get here. 7,000. No, group 3 we don't see. That's the problem here. But we see like the group 2 for January, 25,000, which is the 25,000 from here. So we see the 20, we see the 25. This is right. But we missed the 7 and the 8. with the treatise. So treatise solves some of the issues, but not all of them. We're also happy that we now get the total right. At least the total is right to what the numbers we see here, but we still miss the budget of group 3. And the reason is because we're showing things from the group from the product table, not from the group. Yeah, from the group product table. And in the product table, let's take a look. The product table is the product. This is the budget table where we group 2 and group 3. But on the product table, we only have group 1 and group 2. We don't have any group 3. So that's preventing Power BI also showing this one. So treatise is one solution. I could apply the same thing without treatise by applying many-to-many relationship. So remember, without treatise, without the relationship, we get those numbers in here. If I go over here and take the product group and move it over, I can create a many-to-many relationship. And Power BI is warning me. It's only a warning. There's this yellow part here, but I can click the OK. And it's warning me, you should know what you're doing if you create many-to-many relationship. And please don't take this light. Please make sure to read through this to understand the consequences and to understand if this is the only solution or there would be a better solution. So now we have this relationship here. If I jump back to my report, I get the same result for my budget column in here for without treatise, but still the number, the total is wrong here, totally wrong, and we're missing the group 3 here. So this is not what I'm satisfied with. So what I would be satisfied with is another approach, and that's what I already began here. So I have an approach here where I actually show the different months, the different product groups, and I get the budgets, and I got all the budgets right. So for group 2 and 3, I get the budgets also for the December values here, and then add the sum is right. And what I did here is a good old bridge table. So if you ever attended a class about data modeling, then you would have heard that a many-to-many relationship should be dissolved into a two one-to-many relationship. So still we have a many-to-many relationship between product and the budget table, but now I have this this table in between, which is sometimes referred to as a bridge table. That's what I call them. So this is bridging the gap in between. So I don't have a many-to-many relationship, I have a one-to-many relationship. And how do I build this table? This is not so hard. You can build it in your database, you can build it in Power Query, and in this example, I think I built it in DAX, so we don't have to open Power Query here. So the product group table is a table I created as a calculated table. So if you go to modeling, I think, and then there's this new table, you can create a DAX expression as it tells us here, right? So new table, then you can create a DAX expression to create a new table, and that's what I actually did here. So I took the product group, only the distinct values, so I am not interested in repeating values. I also refer to distinct values of my product group of the product table, and union them. Union means that I take one list and take the other list and put them underneath each other. So I get a longer list with all the values from the first, the distinct values from the first, and the distinct values from the second one. Of course, group 2 appears in both of them, so that's why I again apply another distinct here. That's why it looks more complicated, but it's rather straightforward. And then I use this table to put it in between, and with that, I get the full solution as expected, that I get the right numbers on all the places without having to write DAX and without having wrong numbers in the lines or in the total here. So any questions here? I don't see any questions, so we can jump forward to the next part here. So 3DS virtual relationship. So 3DS actually creates a virtual relationship. Of course, your active relationship is not envy or something about you, but you have to pay a price. So 3DS comes with the price that it's not depending on or related on actual physical relationship. And if you create a physical relationship in Power BI, it will create a sort of index. This will speed up the filter going from one table to the other. With 3DS, we don't have a relationship, so that's why it's like have to build up this index on the fly, so to speak, and this is always slower. How much slower, if you can recognize it or not, depends on your data and many other things, but be careful with 3DS. There's solutions where you have to use 3DS, there's no other solution, then use it. If you can't avoid it, then use the other one, use an active relationship over a virtual relationship. Then the detached table. So the detached table means that there is no physical relationship in the model view. So I have two tables without any relationship there. There is one from a business perspective, but I did not create it in Power BI. Again, this is not good because this physical relationship helps us speeding up the things. If people click on filters or you have DAX formulas calculated, they can depend on the physical relationship. This will be much faster than not having this physical relationship. So you pay a performance penalty here. On the other hand, it allows for complex relationship in DAX because, as you might know, if you create a relationship in Power BI, this relationship in the model or in analysis services, this relationship only can be on one single column. You can only join one single column from one table to the other one. So there's no, it's not allowed to have multiple keys in your, multiple columns in your key. And the other thing is, that there's only an equally relationship. So something here has to equal the other thing. If you have a relationship like greater equal or not equal, something like that, this is not possible in the model. And then we can reach out to this concept of detached tables, that we're not creating things in the model, but creating it in via DAX. And I'm using binning here as an example. So if you think maybe you have a lot of values, but nobody's interested in the detailed values, but you want to put this in different bins, like in low, middle, and high of quantity or something like that. And then we have two solutions. Either we create a relationship of certain case, or create a certain table and then create relationships here, or we use DAX for that. This is what the next demo is about. So binning. So the example here is I have this bin table, which tells me that what quantity I have to put in which bin. So 1 or 2 is low, 3 and 4 is middle, and 5 and 6 is considered as high. Random numbers here. And if I apply this to my sales, I have a quantity of 3 here, quantity of 3 is middle. That means A should appear in the middle section of the bin, right? So I have one sale in the middle section of the bin. Then I have a quantity of 1 for product B. So product B, 1 is low. Product B should have 1 entry for the low section, but there's also one order with 4. A quantity of 4 is middle. So that's why B also appears in the middle section. So we have 2 sales for the product B, with different bins, low and middle. And for the last one, this has a quantity of 5, and 5 is considered as high. So C is appearing up in the high bin here, only 1 for C, and then we also see the numbers here. So this is what we could look up here. So we could, like, now I counted the things. We could also calculate averages. We could show the sales. That's not also important here. The important part is how can I connect the quantity and put the quantity into different bins. The first solution I want to present here is this one, that I created this awkward table containing all different quantities I would expect. So this is maybe hard to create, but it's like not very complicated to maintain. So if somebody tells me, no, 2 should be also in the middle, or 4 is now high or something else, or we have more values, then this could be like an Excel spreadsheet, and everybody could then add those new rows, or could change the bin titles for that. So it's easy to maintain. And when I have this, we can actually create a table, a relationship, because I have this sales table and I have this bin table, and then I create, which seems awkward because usually you create a foreign key primary key constraint, right? You filter on the primary key, but here I'm filtering not on the primary key of the sales table, I'm not filtering on the primary key of the bin table, but I filter on the quantity. So I connect the quantity from the bin table with the quantity from the sales table. And the advantage with that is rather easy to maintain. I mean, this is a stupid table. This is no complex DAX. There's no complex things in the model. The model is rather easy, right? And even if like the sales amount change, or like the other way around, even if like the bins change, that I want to have a quantity of 4 now in the super high bin, that's easy to change on this side. I don't have to do anything on the sales table. So this is a cool approach with the bin table, that I could also have an attribute in the sales table, but if somebody tells me we have to change the bins, then I would have to update the sales table. The sales table is the fact table, and only in my case is only 4 rows. Hopefully in all the other use cases, in real world use cases, this is a big table. We have a lot of sales, right? So this is easy to do. The awkward thing, or the disadvantage here, is that we have to have the exact different numbers. So we have to know beforehand what kind of quantities can appear. So if now a 7 appears, then we get this like in a blank bin. It would not be lost, but Power BI would put it in a blank bin instead of putting it in low, middle, high. That's the one thing. And the other thing is that maybe for the quantity, if we have whole numbers to sale, but maybe we also have like grams or pounds or whatever. So there could be like decimals and decimals with a lot of decimal numbers. So this table would be really, really huge because we have to put every single possible value in there, and maybe we miss something. So if this if the numbers are not be able to be rounded, then this is the wrong approach here. So the other one is to have this. So don't look at this. Of course, everybody now looks at the DAX statement. Don't look at this when I tell you that. But let's start here. So I have another table, different table here. So I have a table not having a value for all my different quantities, but this table consists of a low and high range. So low, the low number starts at whatever how low the quantity could be. It could be even negative, for example, if you do have returns or something like that. And up to 3 would be low. And I put it like that. The first one is inclusive, the other one is exclusive. That means I can put the 3 here and the 3 here, and I'm not losing anything because everything up to 3, but 3 is not included. So lower than 3 would be low. Everything greater equal than 3 would be a middle. So I'm not losing anything. If this would also be including, then there could be that somebody puts in the number 3.5, and 3.5 would be neither including the low nor in the middle. So that's why I have always one range is including and the other one is excluding. And then we have the same result here. So this table is now built on the bin range table. So as you can see here, bin range. And now we have an more or less complicated DAX statement. This complicated DAX statement, let's have a look, is a sum x. Sum x has a table parameter. So the first thing, the most complicated thing, which first ignore, is a table expression. And then I'm summing up once. So every time this table expression returns a row in the current context, I'm summing up one. So I'm not using count, I'm using sum x because it turned out being faster than the count here in this case. So the first parameter is a filter, and within the filter, I have another filter. So this is two filters encapsulate with each other, and start with the inner one. The inner one is filtering the bin range table. This is the table we see up there in this corner. And then I'm looking for the quantity. The quantity means the quantity is a variable, as we can see here. This is like in greenish, bluish thing. Quantity is the sales quantity. So I'm only calculating anything if the quantity in sales has a value. If there's no quantity value, then I don't return any table because this is then filtered out because it has to be non-blank. If it's non-blank, then I check if the quantity is greater equal than the low. Greater equal than the low. Greater equal than blank does not result anything, or the low is blank. Now, of course, in this case, it's blank. And it also has to fulfill that it has to be lower than the high, so lower than 3, or the higher could be blank. This is to cope for that when we are on the high end of our table. So this is only returning something if the quantity is in between some of those rows. It can only be in one of those rows. So this is now returning low, middle, or high, one of those 3 rows. And then I'm checking if there's even something in there. So if this bin variable is even returning something. If it's returning something, then this would be 1, true is 1, false is 0, and then I'm returning 1 or 0, true or false. And if I return true, then the sum x will count something. If I return wrong, the filter is not returning anything. It's an empty table, so it's not counting anything. So this is the high level here. So we can build very complex relationships, but not in the model, only with DAX. So there's a solution in Power BI, but this involves not hard-coded, but DAX code to find out. So then we're coming to the last one. So I think I'm fast enough so we can reach out to the key value pair model, see what's waiting here. So in theory, a key value pair, that's what it actually tells, right? It's a pair of a key and a value. So actually it only has 2 columns. A key, it's like the attribute, that could be the name or the age or the sales or the revenue, whatever, and a value, like Markus or Alcove, New York, whatever. Practically, it has 2 more columns. That means that I usually also have an ID column in there to to um, um, to combine those values, because the name is not just a name, but it's a name of a customer, a name of a person, or a name of a product. So there's also an ID column, and there's a type descriptor, hopefully, because this helps us in making this more dynamic. Because if you look at the table, the value can be anything. This could be a text, this could be a number, an integer, a decimal, this could be a date, this could be a true, false, whatever. That means the common denominator in a relation table would be a string. I cannot store the value as a bit. I cannot store it as a date, because it also has to contain strings. So this is only a string. So it's really hard to find out, and this is one of the challenges. This is like a technical debt, while you have really fun in your application, not worrying about the data structure, being able to add attributes and so on, not fighting against any date formats or whatever. You just put the date in there as a string and you're happy. But like uh, making reports out of that, making those numbers useful for anybody is then hard, because then we have to find out the true um, the true data type. Why is this common, or why do I see this model? Because yeah, for the development, for the application developers, it's flexible. It's like a JSON file. Yeah, you just put in things, you remove columns, you don't have to compile anything, you don't have to think about versioning of transitioning one table schema to another table schema. This is easy too. I totally get this, but for everybody building data warehouses, business intelligence system like me, this is really hard, because I cannot use the table as it is. I have to do a lot of effort, put in effort to make this useful to any report tool. We're not talking about Power BI, any. Yeah? Tableau, Click, they need a table formatted schema, which means that the attributes are in different columns and not just one, just two columns telling you the name of the attribute and the value of the attribute. At least I'm not aware of any tool who can make cool reports just with that. So we have to pivot this. So we have to put the key column then has to be our, the content of the key column has to be our columns in the tables. So I have a name there, I have an address there, I have to make a column called name, I have to make a column called address, and then put the value in there. And of course, if you work with that, also think about that this is the first step. Then you also have to make a star schema out of that. Most probably, this is containing facts and dimension attributes in just one table. And this is what we do not want to have in BI systems and data warehouses, especially in Power BI desktop analysis services. They really shine with star schema. So jump over to the last demo of this talk, and we are going to be here. So this is an key value pair schema table. Like I have a key column, I have a value column, and I have this ID. So the first columns there are together. So the city and the name. Bill lives in Seattle. Obviously, first purchase was in the 80s. And then we have another one also living in Seattle, Jeff, who first purchased in the year 2000. And there's also this guy Markus somewhere. Do we have a name here? No, this last no, here we have the name. Yes, Markus, who lives in Alkoven and did the first purchase beginning of last year. So this is the table. And there's actually one cool thing we can do with this table, and this is what I want to show you before we then solve typical things. So we can have these counts in here. So what I put here is that I have this table. For example, I have now the names in my rows, right? Bill, Jeff, and Markus, and I put the city into the columns. And this is built upon just this one table. To be sure, it's two tables. I copied the key value pair table 2 times, and I think I can. That's why I have it like this. So now the end user can like decide, no, I do not want to see the city here. I want the zip codes in here. So we can remove the city and just put the zip code in here. And this is very, very flexible and can get the count. So how many bills do we have? It's just one. How many people do we have in this zip code? It's just one. We can also have the revenue, the first purchase, whatever. So the end user can decide on what to see. This is really, really flexible. So for some occasion, for some specialty reports for the power users, actually the key value pair report can also be, or a report depending on this key value pair table, can be really, really cool. But what you usually have is that people want to see the actual names and numbers. So typically, this is more typical. Like you have a table visual, or you would have a bar chart or column chart or trend line or whatever to see different attributes. So what I want to see, the cities of those different people, the names, the revenue, and so on. but I also, for the revenue, I would expect that I get the sum, the total down there. And this is hard to do because, as you can see here, like you can see from the format here, this is still a string. I mean, for me, revenue means this is a number. But Power BI, in Power BI, it's not stored as a string because that's what we get delivered in the key value pair table. The value is a string value. So we have to do different things. It's not enough to just pivot this in a visual. This is what I did here. So if I take a look on this, this is just a matrix visual, and this matrix visual has the ID in the rows, has the keys in the columns, and then the values, let's put in here, and then the values in the value section. So this is one thing that we don't, I mean, I turned off the total because the total would then show, for example, Eindhoven as a total for the city, which doesn't make sense. I only want the total for the revenue. This is not possible with just the matrix visual. That's the first thing. And the second problem is that as you can see it, this is value. It's not just value, it's first value. So there's some function applied to that. And you can choose between first, last, and some counts. We cannot say please show all of them or there is only one of them because why is this necessary? Because in theory, in this table, there could be two rows for the customer one with a name and two different names. So we have to tell Power BI what to do with that, and the standard ways are just showing the first, alphabetical last, or counting all of them. So what we can do here is different approaches. So I have a solution here. Not able to show everything in detail in the last 3 minutes I got here today. But what we can do is we can build DAX statements again. Yeah. So for example, for the city, I made sure that this DAX statement, make this bigger, this DAX statement shows whatever is the content of the city. So we show the city is we show the value, right? We show the minimum value again. If there's two different rows, we only show the minimum one. And we only show something if there is an ID. So for those where we have one single ID, has one value ID, we show the city. But for the total, we do not. Because then, in the total, remember what I explained about the budget. The only difference for the total is that there is no filter applied. The filter context is different. So there's no filter on the ID. That's how I know, now I'm in a total. And if has one value, then I show the minimum one. Else is empty, I don't return anything, so that's why we get the blank here. So this is how we can solve this with DAX, but this means we have to build for every single attribute in our key value pair table. Now we have to do some DAX coding. So all the time, all the effort the application developer saved is now on us. Now we have to create things in here. So if they add a new key in the table, new column with a new row with a new key, we have to go there and then change the DAX code and add another measure in here to cope for that. For the revenue, it looks different. It's just filtering everything on the revenue. That's when I know that I'm revenue, and then I convert the value function allows me to convert a string into a number. That's the function here in Power BI, and that's how I can transfer this. Now you see this is actually a number. It's formatted as a number, and we get also the total down there. So this is the hard-coded solution, and you can do this either in DAX, you could do this in Power Query, you can do this in your database via the pivot thing. All of them are in principle hard-coded. And for the last 2 minutes, I take the approach what I did here. I have a more generic solution here. Let's stay with DAX here. So what I created here is another measure, and this measure is the generic value. That's how I called this measure, called generic value. So I'm not building one single measure for everything, but I just put the keys into the columns like we did with the first visual, and then put the generic value in there. And this generic value is what we get from here. So click the generic value, and then we can see the DAX code. I think I can zoom out here because this should be big enough for everybody. So there's again, more DAX code in here, but this saves me from creating a new column, a new code in DAX for every single column. And first I make sure that I know that I'm a numeric column. So my numeric column, for example, could be revenue. I could change this in here. That is even a more generic one. This is this one, which is not finding out the numeric columns by names, but searching for that I get in this key value table. I think I did not show you the full key value table because the full key value table also has this type column. So this is what I get here, the type column. And then I look for types like the integer integer 64 type, I know this is a number. And then I treat this as a number. And that's what I do in this full generic one. So I find out all the columns which are of one of those types. And this could be anything. If the developer put in a 1 for a number, or like number, or like Hugo, or whatever for a number, I can just put it in there. But I'm not looking for actual values of their keys. And if it's a numeric value, then I convert it again, like with the code we have previously seen. If it's not a number, then we again have this has one value, and in this case, I concatenate them. I'm not looking for the first one, but if there's two different names, I put in Jeff, comma, Bill. So I concatenate those values. And that is what I return. So if it's a numeric value, if it's not a numeric value, sorry, then I return this non-numeric value code. If it's a numeric value, I return the other code. So that's I can then get it very flexible. So I'm not depending on the actual names, only on their types. And to select different columns, I can just put in the filter here and decide that I also want to see, I don't want to see the city, but I want to see the name instead. So just exchange or add things here over the filter. So also very flexible. And the same approach you can do also in Power Query. So I have a Power Query which is also looking for the data types, and in the data types, from the data types, it knows then what to transfer what. So I get actually columns, real columns into the model. This is like what we have in this final here. So this is done over Power Query, that I get actually real columns with the corresponding types. So the revenue is actually a whole number, and the name is a string. And I don't know what else do I have here. The first purchase should be a date. So this is what Power Query then takes care of. And you can also push this even further. That's actually the solution which brought me to mind to make a talk out of that, is that I solved this in SQL, in Power Query, not in Power Query, but in SQL, so Azure SQL DB, where we get also this key value pair, and then I use pivot, the pivot function of SQL. But of course, pivot again, you have to hard code the things. You have to name what kind of values you're expecting. So instead of using pivot alone, I built a dynamic SQL script. So it's a procedure which creates dynamically a SQL script, creating me the full table with all those columns I need with the right data type, and creating a procedure filling this table from the stage table which we receive, and a view upon that, which I then uses an API to Power Query. So Power Query should not, or analysis services should not directly connect to tables, but only to views in case we change some of the schema here. So there's also full dynamic solutions there, but this is the technical depth you build upon, and I would solve it rather in the application. So I would be happy if the application could deliver real tables, but sometimes this is not possible. And then at least I try to solve it as early as possible. So either in DAX, if this is the only thing you know, then use the solution in DAX. If you can use it in Power Query, use this one. But if you can push it to your data warehouse, of course, do it there. And that's summing up what we can do with key value pair tables. So jumping back, so this is what I do here. This is what I did in Power Query. So I'm the slide deck now showing what's the solution in Power Query. And hopefully you have some takeaways. First one, always use star schema. Stay away from many-to-many. Stay away from bidirectional filters. Stay away from, or review what Power BI creates for you, because sometimes it doesn't get it right. And only in certain rare use cases, reach out to specialties and also those nice features we have. So the many-to-many relationship is not there to just use it. Only use it if it's really, really necessary. So make your due diligence about that. And also the second takeaway is that you always can exchange what we have seen with the binning. Either we have like a simple relationship, no DAX, or we have no relationship and then do everything in DAX. So we can, in many cases, exchange the complexities in the model with complexities in DAX. Yeah, Power BI is optimized for star schema, is optimized for one-to-many. I cannot repeat this enough. Yeah, so please stay away from many-to-many detached tables and key value pairs, even if we talked about that, because this is rare use cases, and hopefully you can use it if you really face those rare use cases, but just don't use it in when you're in doubt. Yeah, there's a list out there, instructions, and thank you very much for Tony and Martina organizing this conference. Thank you very much to all the sponsors. Thank you very much to all the speakers who speak there for free. So I hope you enjoyed attending this conference. I hope you enjoyed watching all those videos we provide here. And if there's anything else, please follow me on Twitter, add me on LinkedIn, and contact me.